Hello guys, welcome to Math Vantage. So in this lesson we're going to talk about the tree diagram for drawing without replacement, which is the example number 2. The example 1, it was drawing with replacement. If you didn't see that video, go to check the description below. There is a link for the example 1 of the tree diagram, drawing with replacement. So now let's talk about drawing without replacement. The statement says a bag contains 6 red balls and 4 blue balls. The 2 balls are chosen from the bag one after another without replacement. So it means we're going to have the first branch, which here is going to be red, and then here it's going to be blue, because we saw that the 2 balls are chosen from the bag one after another and without replacement. So meaning after he chose the ball, he kept it to himself. He didn't replace that ball to that bag they were using, right? So it shows that the total number of the balls changed now. So but then before I can confuse you, let's now solve this question. So now we have red and blue. How many red balls do we have? We have 6 red balls. How many blue balls do we have? We have 4 blue balls. But then remember that we are dealing with probability. So we must write our values in a probability manner, right? So it means we must divide by the total number of those 2 balls. What is the total number of our balls? It's 6 red ball plus 4 blue balls. So 6 plus 4 is going to give us 10. That's when we write 10 here. And your answer here, whenever you add this value, you must always get 1. It's either 5 over something, but whenever you add them, you must get 1. So if you add 6 over 10 all over 4 over 10, you're going to get 1, right? So therefore, we are done with the first branch. Therefore, the second branch, we are told that he chose that value without replacement. So meaning now the total number of the balls has changed. Now we have red here and we have blue, and we have red, we have blue, right? So now we are told that without replacement, right? So because of it's without replacement, and now we're on what? On the red branch, right? We're still on the red branch. So as we are on the red balls branch, it means now the total number of the red balls is going to change. It was 6, right? So we need to subtract it by 1. Therefore, it means we're going to have 5 all over. Therefore, now remember that the balls are like after he chose the ball, it was not replacing them. So it means also the total number has changed. The total number of the balls, it has changed to what? To 9, because it was not replacing the balls, right? So now we have what? 5 all over 9 for the red one. So now we come to this one here. What will be the value of here? The value of here, obvious, we know the total is going to be the total of balls, obvious, it has changed to 9. Therefore, what about the blue balls? Is it 4 or it's going to be 3, right? Remember that now we're on the red branch, so meaning it didn't affect the blue ball. So it only took the red ball, not the blue ball. So it means the blue balls were not affected. That's why we still have 4 all over 9. And how can you prove it that the 2 values that you wrote are correct? If you add these 2 values, you must get 1, like I said earlier. So you're going to get 1. So we're done with the red branch. Now we come to this one for the blue branch. So when we come to here, we know that the total number of the balls, it has changed to 1, to 9, right? Therefore now, which value do we write here? We write 4 or we write 3, right? We are on the blue branch, but then we can see that this blue branch, it goes with what here? With red. So do we write 6 or 5 here? We are going to write 6. Why do we write 6? Because we are dealing with the blue balls and the red is not affected in the blue balls branch, right? Only the blue balls is affected. Therefore, now here we have 9. The total number didn't change. But then what will be the value here of the blue ball? Is it going to be 4 or 3? It's going to be 3, right? Because now we're dealing with the blue balls and we also have blue ball here. So it's going to be 4 minus 1, which is 3. And if you add these two values, you're going to get 1, right? Therefore, it means now the outcomes we have here it's red, and then here it's red and blue, and then here it's blue and red, and then here it's blue and blue. Can you guys see it? So the first question says, what is the probability of choosing the two balls of the same color? The two balls of the same color, we can see that the first one here, we have the two balls with the same color, and also here, the two balls with the same color. So the probability of R and R plus probability of B and B is going to be equals to, what is the probability of R? It's going to give us 6 all over 10 multiplied by 5 all over 9. We're going to check these two values here. It's for R and R, right? Therefore, plus for blue and blue, it's going to be 4 all over 10 multiplied by 3 all over 9, whereby the answer is going to be 7 all over 50, right? Therefore, we are done. This is how we solve the probability. If we were asked to determine the probability of red and blue, if we were asked to determine the probability of red and blue, where's red and blue? Red and blue is here, whereby the values 4 and 9, 4 all over 9 and 6 all over 10. Means we're going to have 6 all over 10 multiplied by 4 over 9. Then we are going to get the final answer. So this is how we solve the question of drawing without replacement. So we are only left with two examples whereby we are going to talk about the possibility of the outcomes, which is the last one, and also how do we solve the tree diagrams whenever we are given the probability of 6 red balls and we are told that for the blue balls it's unknown. Therefore, how do we solve it? So yeah, this is the end of the today's lesson. If you find this video useful, kindly subscribe and like, and don't forget to share it with your friends. Thank you.